Lekazir anober mai lekazir anober mai lekazir anober mai kan shiat ngai lo le zir ngai lo te po kan hu lo le kan cho ngai lo te po izir zelang so turin izir zelang so turin lekazir anober mai lekazir anober mai lekazir anober mai.
Hello guys, in this episode I shall talk about magnetic flux and I shall explain with aids, and I shall also write about its equation while I'm explaining with pictures. So what is magnetic flux? The magnetic flux linked with the surface when held in a magnetic field is defined as the number of magnetic field lines crossing the surface normally and is measured as the product of component of the magnetic field normal to the surface and the surface area. It is a scalar quantity and is denoted by pi. Okay. So what is magnetic flux? Katikaron sharing of chuan, you may not be able to understand. Okay, kain tre thiam kherlo mai thaya. Bar magnet in train karinga bar magnet. Jo magnet mo ta chuan a magnet khan a lower class at the pok kan mutoim kashalo. We might see that from north to south. So it's originating from north. We usually draw a line, isn't it? Line tam tak kan draw trina. Lau chuka ti chun south pole and trini magnet ka. And if you look this picture, okay, in a figure number 1 you can see that bar magnet. So you can also see number of lines of force. Magnetic field lines kan ti kimi line tam tak ki lines of force antia. Tiang kian om chau trinani, but we cannot see with our naked eyes actually. Kan mit long kan mulowa kami ha field siam tu ber chunitani lines of force tam tak oma. Kimi line tam tak ki lines of force anti chunitania. And also in figure number 2, not only in magnet, in a charge, negative la positive charge lo ta se mo chuanin line ki ve thoni chu. It's originating from the plus, the positive charge. Okay, positive charge rang kan originate chuanin negative line tam tak kan draw veni ki chu. It's not a magnetic lines of force, it is electric lines ani ve thoni chu, electric lines of force. Magnet chuan magnetic lines of force anti electric charge chuan it is an electric lines of force anti tani khitiang chunga khian mo kimi line can if you put some small area, maybe an iron plate amo engemo thil poka chunga da tawla chuan lines khana cut don e chu tan tlang don tani chu. So the lines of force will cut or will pass through or will cross. Okay, the lines of force will cross the surface normally. This is not tan tlang don tani chu. Chung chu exact nganiang antinan king a line ki tam tak za lo ni ta sentirnan, for example 100 lines but 20 cross the lines. Okay, 20 cross the plate. A plate ki som nivel in lo cross ta chuan chunga cross tu zong chawa chu kan soi don tani across tu chu. So the number of magnetic field lines crossing the surface normally kan tika magnetic flux anti chuni tani chu. King zong zong ki chu lines of force anti veka lines of force zong zong zinga khian across to kami area tero te cross to zong kha la khom khan magnetic flux anti big tani chu. Kami magnetic field can affect kalo ni tani chu plate ta emo thira emo engpok achu kan da khan chu apoi mo ani ki electromagnetic induction theory chun abul thut ania tin magnetic flux omji ha kan thria tangai kan la soi fo do na magnetic flux akha ti chuan a question ha karon ziak karon swinga a picture nan karon sui til ngal donai tikhan magnetic flux e omzia chu you can rethiam ome lines of force zong nilovin a area thil pakhat kan zuda a khalai pass through ho zonga kha kan la khom magnetic flux chuni tani.
Okay, let me try to explain with the help of this thermocol. And this is rectangular shape. It's have an area loni tani kan shia so length into breadth kan theng chu no length into breadth kan thenga. But in the lower class we know that area is a scalar quantity and it have no vector, isn't it? We don't study about a vector of an area of a field, okay, an area of a plate, maybe area of a book, an area of a wall. So it doesn't have a vector quantity. It doesn't involve vector quantity. Vector quantity omaniti kan thengai lo amaro chu tu na chuan in class 12 level a chuan area hi vector quantity ne ya poimoni ti kha kan zir pa dona in chuta chuan inge magnetic flux ne relationship kha kan sei bok dona ni. So this is a scalar quantity, simply a scalar quantity, length into breadth, isn't it? But we must know that there is suppose there is a magnetic field is coming. So many lines of force tam takati in local tani lines of force. So as I have said before, the magnetic lines of force crossing, okay, and it's crossing here and there. So many lines of force. Allow cross tani too, magnetic lines of force akan. Tichuanin area it's have an importance area more. And also one thing, so if I rotate, for example, if I change the position of this area, then the magnetic flux link with this area will also, the value will also be changed, isn't it? At area po khatang lam don tani chu function area ringot ba ka hian a position angle kha apoi mo tani chu. So this is an area we always draw a normal I think can draw thin ni chu eng po hi normal can draw thin a line taka perpendicular to the plane, okay, perpendicular to the plane. For example, this is a normal, so I have draw a normal, this normal line is not present actually, but it is a reference line so that we can know its angle when the magnetic field or electric field cross this plate, okay, can fit in a turata reference line kind of tani too. So it's always perpendicular, okay, from the plate, not inward. For example, this, let me take this. Hey niya, normally draw down rang chuan a panga zel, so normal ani turni. And anwaya ni chuan tihian outward perpendicular niya. You must not draw inward. A chung zong draw lo turni. Hey korong tani, it is a hollow cylinder, but you must not draw the normal inward. We should never draw. A normal to a pangzela perpendicular. We cannot draw like this. You should not draw normal. It's always perpendicular turni. A pangatrang area, circular area, isn't it? So pangatrang is in the middle. You can draw zel tani chu. Yan. Chu normal kan ti chu ni nge normal chu nakina magnetic field lines local nga chu min na angle in car kan thret hina in order to know the angle between the normal, okay, and this magnetic field lines, okay. So this is a rectangular shape. It is a rectangular shape or plate, isn't it? So we draw the normal lines. So now when we put inside the magnetic field ka line tam taka local tani chu coil kan ti te pokhadar te iron plate, maybe aluminum khang jong ka chu hang kan data chuan and cross tani chu plate a khan chuan line field lines ka tam taka local tani chu mo field lines ne an angle ka now it is parallel, isn't it? A parallel tani chu lahian. So the angle between is taken as cos theta, okay, cos theta tani. The plate is simply a scalar quantity, but now I am going to rotate slowly, so it's rotating, so the angle is changed, isn't it? Angle lomta cos theta, the angle, the theta will change, isn't it? If I change and change again, so now is changed. Now it is perpendicular. The normal and field, magnetic field. Think this bamboo stick as a magnetic field. Magnetic field lines of force. There are so many lines of force, but I represent only one. Okay, in order to explain it. Explain nan kan pahat ka kan pangtani chu. Mo, this one hey, the field lines kala normal dan cos. It will be cos 90 alone down at nature. When they are in parallel, cos 0 on the nature. Which one cross? When it is cos 0 ni like a plate erotu, they are in perpendicular. The field lines and the plate are in perpendicular. However, the normal nature parallel. We must think only the normal, not the plate. Okay, not the position of the plate. No, so normal nan the kind of angle change. Maybe 30 degree, maybe 60 degree. Okay, maybe 70 degree and 90 degree. The kind allow position color change the gel and it's more. Then can Kakapoy mo khop maya. Chuan plate scalar quantity ania but so when we rotate the angle it have some value dang lo le tani chu chuan we call it a vector aerial vector kan ti tan chu vector nei ta ka wang aerial vector lower class chuan kan hrengai lo renga aerial vector nei amaro chu tuna higher class chuan when we rotate it will have some value can change position can change kan area khan chuan area vector an ti tani chu area vector kalo poimo ta mani area kha when it changes the position it changes its angle then it will have some different value. This one the magnetic field lines kalo kala then it will cross. Then when I change the position then the angle will change. If the angle is changed that means the value will change, isn't it? Value phi will be changed. Phi magnetic flux will change. The effect of the magnetic flux with this plate will change. Magnetic flux the hemi in link dan color change don't turn it. So it is something like water. Tui antirnan tui noa hian lo chung tani. Water, you pour some water. Think that the water falling drops of water are magnetic lines. Ahan lo ngai taila tui tam takalo chung dota. Hani le tui kang tin ngai idon tamberan. Don't tamber heti hian tro. In this position you will get the most volume of water, isn't it? But if you change this the angle, if you tilt no kailo position change chuan, then water will fall down. Still water will fall down, but some part will enter. Some part that means the magnetic field lines will enter. But if you then increase its angle slowly, then when it is perpendicular, or we can say the water is entering, the normal you should draw is like this, isn't it? So tui ka kan mu thei ber tur chu engzang kha tui a local light tur chu a local khan lo tlak khan tui kha kan mu tam ber thei tur chu normal le hemi hi magnetic lines kha a in parallel light in ane chu mo cos 0 ani khan cos 0 maximum alone don ani chu maximum we get the maximum value of magnetic flux, the maximum water khating che ma se heti til zel chuan the normal is like this. Hemi bang, we think about this plate. Helam pang side tani kan ngai to. Helam pang side kan akwo kha ti hian normal chulom tane chu. So the normal of this mouth we can say hemi kwa le tui magnetic lines of force are in perpendicular. So you may not get any amount of magnetic flux, or we can say you may not get amount of water. Tui chu lo lut lo ang tro. Chu tiang check chuan ani magnetic lines po kha plate khan. So it has a maximum and minimum value. So magnetic lines of force is crossing, and when I tilt it then it's decreasing. So many magnetic lines are passing away without touching this untouched talotani. Hetical se parallel phei chon hei tam takhan afu to don lo ni chu afu to don loba. So when the normal and the magnetic field lines are parallel in perpendicular means 90 degree cos 90 will be 0. That means in theory there no magnetic field line touch, but some part it will touch if it is thickness is some amount. Okay, that time chuan a theory chun 0 ni ma sela hey plate touch ha dana zir khan plate tlang te chu afu ve mai thei magnetic lines chen khat khan amaro chu a theory tak taka chuan mo chu bang chun amak hemi zo hin kan derive don ani kan siek don equal phi equal to B, that is magnetic lines normal to the surface, okay, into area. Okay, so the angle between is cos theta. That you can read on here. So phi is equal to b delta s. We can say delta s means area. Okay, sin cos theta, angle between this. So we write like this. I'll tell you how to write it. Okay, how to express in equation. Okay, so there is an importance of areal vector in magnetic flux. So the magnetic flux in the air is linked between each other. Apoi mo mm ju hemi te pan hi link ta ni chu wang chuan magnetic field flux amo effect kan ni tam du chuan a parallel lovin a perpendicular kan da tam ber maximum kan hunga, but a touch lem chuan a tlem la engin magnetic force a pass chuan ti chuan a tlem lai ber chu magnetic field magnetic flux lem lai ber kan budon ti na ni chu tiang chuan i omzia alo nei ta ni chu mo magnetic flux omzia chu kha khan ta ni plate nen a in link da na khan kan thata o me tuin bucketa ha tam lai ber fu tam thei lai ber anei ang chi khan bucketa mon nowa tuin don tam thei lai ber anei ang chi khan hati kan ti chuan adong tlem til ang chi khan magnetic lines of force pon effect kha adon ten tam thei lai ber anei ta ni chu mo dynamo te ka avir thin ta ni chu dynamo mo generator kan ti kha magnetic ka han ten avir thina avir khan don tam hun le don tlem lo nei ta thin ta ni chu kha ma se pui mo na chet reng ngai ta ni chu Michael Faraday ana hu chuang khan magnetic flux a chet reng khan I current lo in siam thei ti kha hu chu khan ya chet reng ngai ta ni chu bang chun fil khan ti vir thin ta ni chu. So dynamo or generator, inside generator there is a machine which always rotates, so it will cut the magnetic flux. So when the magnetic flux is always changing from maximum to minimum value and minimum to maximum value, we'll get the value of some current, some amount of current from maximum current to the minimum current. So we get alternating current. This is very simple. Okay.